Hey guys, it's Signal. Welcome back to another video. Today I'm going to be going over just some basic OBS settings. This is mostly targeted towards new content creators / esports coaches, believe it or not. So right now I am an esports coach under the NJCAAE, and right now there are a lot of coaches who struggle with the more technical aspects of stuff. So they might be really good at coaching the game that they coach or handling players and stuff like that, but they might not be as good with the technical side of things. So that's kind of where I'm coming in, making these videos to help you guys out. But this can also be used for people who are getting started with content creation. So once you install OBS, it's going to ask you about an auto configuration wizard. My advice is just hit cancel and then follow along, as the auto configuration wizard can give you an okay place to start, but it's usually not ideal. So I'm going to go through all of the settings in OBS and kind of explain what they do, specifically the encoder settings. Now, if you want to use one of my templates here I have made, you can import profiles. This is also a great way to be able to kind of save profiles in case you ever have to install it across multiple instances of OBS, or just as a way to back up your settings. So first, if you want to back up your current settings, if you just hit profile and then export, and then you can choose wherever to export it as. I'm just going to export it right to my desktop, and I hit select folder there. It exports it. I now have a folder by the same name as my profile here. However, if you want to use some of the OBS profiles that I have already made, I have 5 of them here. One's for a dedicated stream PC. One is for a fancy high-end system, kind of like the one I'm running right now. I tuned the extreme profile around a Ryzen 9 5900X and an RTX 3080 Ti. High-end, mid-end, and low-end are also like vary in degrees. Low-end is like a 720p 30 FPS stream if you're trying to stream off of a pretty weak computer. You can experiment with these. So to import them, you just hit profile, import, select the folder. I'll select dedicated stream PC and then hit select folder. And now if I go over here and check this, it now changes my settings to reflect the whatever I have set. So I'm going to have to go through and actually re-update these because I already had a version of this video recorded before the OBS update. So I will update these to better reflect the current settings and the new recording formats and stuff like that. But this still kind of gives you an idea of what you can do. So you can actually import and export as many profiles as you want. So if you want to have 2 different profiles, one for FPS games that are fast motion, and you want another profile that streams at like 1080p 30 FPS for slower motion games like League of Legends and stuff like that, you absolutely can do that. So if we click settings here, we get taken to a general tab. Most of this stuff is pretty self-explanatory, so I'm not really going to go over anything here. Next, we have the stream tab. This lets you select what service you want to stream to, the most common being Twitch and YouTube. I have more experience streaming on Twitch than I do YouTube, so I'm going to be basing my stuff around Twitch, but YouTube should be fairly similar, and if there's any major discrepancies, I will comment on those. So if you select Twitch or YouTube, what's nice is you can hit connect account and it'll connect your account directly to OBS, which lets you see chat inside OBS and all sorts of cool little stuff. It also keeps you from having to go through the process of getting a stream key and pasting the stream key into OBS and doing it that way. So if we go over to output, by default, you're going to have it on simple. We don't want simple. We want all of the options available to us. So we're going to hit advanced. This now allows us to have separate settings for streaming and recording, as well as gives us access to audio settings and a replay buffer. I'll quickly go over the replay buffer. It's pretty self-explanatory. What that does is it is kind of like NVIDIA Shadow Play, where you can capture the last couple of seconds or couple of minutes of whatever just happened. So you can actually do this inside OBS. You just check this box and plug in how much time you want there to be. It goes in seconds. So if I want 5 minutes, I do 300 seconds. Pretty easy. And then if I hit apply, I now have a button right here that says start replay buffer. So what I can do is I can start the replay buffer, and then anytime I want to capture from it, I set up a hotkey. So if I go to hotkeys here, I can hit start replay buffer, and then there's a stop replay buffer, but we want to go down here to save replay. So after the replay buffer started, after 5 minutes have gone by, I can press save replay and it'll save the last 5 minutes that was recorded. So that can be good for things like clips. So just keep that in mind if you want to go that route. This is pretty nice to have. Audio just lets you change the audio bitrate on a track by track basis. You probably won't have to worry about this too much. If we go over to recording real quick, I just want to go over this recording path right here. By default, it saves it into the videos folder of whatever user account you're signed into. I personally like to change this to a network drive, especially if I've got a lot of footage that I'm recording. So I like to just offload it to a big network drive or just a big hard drive somewhere where I'm not, taking up whatever space I have left on my SSD. That's my C drive, just filled with garbage footage. Let's go over to the streaming tab. This is going to be kind of the bread and butter here. I'm going to jump around a little bit because a lot of settings tie into each other one way or another. So I'm going to try to explain this in as simple terms as possible. For audio encoder, I believe there are a couple of ways you can get this to not only say FF, MPEG, AAC. Unless you're a big audio person or a big video editor, you can leave this alone and it's serviceable. It's perfectly fine. Video encoder is where things get interesting because basically you have a couple of encoder options and the options you do get depend on a couple of things. So since I am streaming to Twitch, or since I have in my stream service, I have it set to Twitch, Twitch only supports 2 options. This is also based on my hardware configuration as well. So I can either stream with X264 or NVIDIA NVENC H264. However, if I wanted to stream to, let's say, YouTube instead, and I hit apply, and I go back here, I now have more options, namely the AV1 encoder. Now, AV1 right now is the newest encoder, so it looks the best, generally speaking. It looks better than X264 in a lot of ways. However, not every platform supports it. Like I said, Twitch doesn't support it right now. But also, not every editor, as far as I'm aware, is going to support this. I haven't tried AV1 yet. I've just been kind of reading about it and hearing about it. So, if you see these options, play around with it, try it out, and see how it goes. So NVIDIA NVENC H264 and X264 are basically the same thing. It's just a difference of, do you want your processor to do the encoding or do you want your graphics card to do the encoding? So since I have an NVIDIA graphics card, I get access to the NVIDIA options. AMD has their own version of this. I forget exactly what it is called. So you can use that if you're running an AMD graphics card. Or if you want to play it safe, you can just let your CPU do it. However, letting your CPU do it comes at a cost, especially for esports titles. Esports titles generally use your CPU more than GPU. Esports titles are usually graphically simple because you're trying to get the highest frame rate possible. But since you're trying to get the highest frame rate possible, that usually pegs your CPU usage up pretty high because the CPU is trying to output as many frames as possible for physics and game calculations and stuff like that. So if you encode on the processor, you're going to notice a pretty significant hit to your frame rate when you're playing games. So if you're streaming and gaming off of the same computer, my advice is you use your graphics card encoder, whether it's NVIDIA or AMD. I'm not counting on any of you guys having Intel Arc GPUs, but if you do have an Intel Arc GPU, those are native AV1 supported, and AV1 works great on those. So that's kind of the main difference. And then you have this NVIDIA NVENC HEVC. I don't think AMD has an equivalent to this yet, but this is better than H264, at least slightly in my experience. So if you have this option and you're using an NVIDIA card, yeah, go for it. This is probably the best option if you're streaming and gaming on the same computer. If you have a dedicated streaming PC, or you have the luxury of just having a machine on standby that you can use to do encoding, set it to X264. This is still technically outside of AV1, as far as I'm aware, the best option for encoding. It looks the cleanest. Moving on, now that we've kind of got the encoder out of the way, I'm going to set this up like I'm streaming and gaming on the same computer, so I'm going to actually let this run on the GPU. If we go over to Rescale output, we can rescale our output to a custom resolution. I'm going to explain what that means here in a minute. If we go over to video, we have our base resolution. Usually this is just the resolution of your monitor most of the time. So I'm running a 1080p monitor, so my base resolution is 1080p. Now your output resolution is what you want to record at / stream at. So if you leave this rescale output unchecked, it'll use this output resolution as its value. However, I'm in a position where I want to stream and record at the same time. I want to record at 1080p at the full resolution to get the highest possible quality for my clips or for, whatever. But when I'm streaming, I don't have the capability of making 1080p 60 FPS look good on stream. I'll explain why in a minute. So I want to stream at a lower resolution to make it look better. Again, I'll explain why you do that in a minute. So I'm going to leave this output scaled resolution at 1080p, and I'm going to stream at 60 FPS and also record at 60 FPS for that matter. If you want to stream and record at 30, you can change this. As far as I'm aware, you cannot have two different FPS values. You can't stream at 30 and then record at 60. But if I go back over to my output tab, I can now, under the streaming tab, hit rescale output. And now I can set this to 720 if I wanted to. And you can type in whatever resolution you want. You can also hit this drop down here and it gives you options. But now I can basically stream at a different resolution. There's a little bit of controversy surrounding if you should use rescale output or not. In my experience, it works fine. Some people say it makes it look worse because you're not running through a downscale filter. So I can kind of understand that there. Basically, your mileage may vary. Something else for this rescale output, and this is where we get to talk about bitrate and rate control and stuff like that. This ties in with the encoder. This is basically the amount of data you pass over to the encoder. So think about it this way. Here's how I'm going to explain bitrate in the simplest terms as possible. Let's say our video is represented by these 64 jars I have here. And let's say I have 64 orbs here, and each orb needs to go into a jar. So how a traditional video would go is, every dot gets assigned a jar, like so. Every single dot gets its own jar. However, let's say we have a lower bit rate. Let's say we have only, half of the amount of orbs represented here, or data is what this is representing. So now the encoder has to effectively spread them out. So it might fill one here, it might fill one here, it might fill one here, depending on what's going on in the scene, but it only has so much data to allocate to the entire frame of video. So this is why running at a lower resolution with the same bitrate tends to look better, because it is better to have less jars. So let's say I got rid of half of these jars. Now every jar has more data in it, which means it's going to look better. Does that make sense? Whereas on the flip side, if we had more jars, if we had double the amount of jars here, let's just say we had way more jars here. Now, again, it's having to spread them out. And encoders will use clever tricks like HUD elements and stuff like that. Anything that isn't a moving pixel, or like that part of the image isn't changing, it'll usually be okay to keep a dot there, let's just say. So that's generally how bitrate works. That's why having a higher resolution is less desirable if you don't have a very high bitrate. So usually there's some general guidelines you can follow. So for Twitch, the highest you can stream at without being a partner is 6,000 kilobits per second, or 6 megabits per second if you want to translate that into megabits per second. That's usually what your internet speed is measured in. YouTube usually has a bit of a higher limit. I want to say it's like 10 or 12,000. I think technically they support higher if you're streaming at like 4K or something like that. For general rule of thumb, stream at, usually if you're streaming, don't stream at 1080p unless you're streaming to YouTube and you're running at least like 12K bitrate. 10K can look okay, but if you are really dead set on streaming 1080p, change your frame rate, set it to 30. That'll also lighten the encoder load because now it's only having to put half of the frames a second. So what I usually do is 720p is a bit too low for my taste, especially at 6K. But 1080p, the 1080p is too high for 6K bitrate. So I like to stream at 1664 by 936. That's kind of a halfway point. That's also a 16:9 resolution. The other thing too is that the encoders usually like to work with multiples of 8. So both of these numbers, the horizontal and vertical resolutions, are evenly divisible by 8 with no remainder. So that'll also help a little bit in keeping the picture quality looking clean. Rate control basically just determines how this bitrate is actually allocated. CBR means constant bitrate. It means there's the same amount of data for every second of video, no matter how static or how dynamic that frame is. CQP works a little bit differently. It is an NVIDIA NVENC exclusive thing, and it's actually what I like to use for recording because it actually looks pretty good as far as just a rate control management. That's just another thing that you can kind of experiment with. CQ level, how that works is basically the higher the number, the worse the picture looks. The lower the number, the closer to, I guess, raw data it looks. VBR stands for variable bitrate. Basically what it means is there is a average bitrate value right here. That's the amount of data it typically targets, but then if it needs to, you can specify a max bitrate. So you could say like, oh, well, if I have a frame that's like, let's say I'm like streaming an FPS game and there's a lot of movement on screen, it's okay for the bitrate to jump up to 10,000. VBR is okay for recording. It helps you get kind of the best of both worlds between file size and cleanliness. But for streaming, usually you have to use CBR most of the time. CQP again is good for recording. VBR is good for recording, but CBR you usually have to use for streaming. Keyframe interval. Most of the time it's okay to set this to 0. However, I do know for a fact that YouTube and Twitch both recommend a keyframe interval of 2. So I'm going to set that to 2. Preset here, again, this is an NVIDIA NVENC exclusive thing. This basically just determines like the amount of processing power your GPU uses to encode. If you have a remotely capable gaming graphics card, set this to 7, best quality, play around with it. You should be able to get away with having it on best quality without any noticeable drawbacks, but if you're noticing some weirdness or the computer lags out significantly, see if lowering this does help. Tuning, just leave it at high quality. Multipass mode, this basically just tells the encoder how many times to go over a frame. The more passes, the better. So a single pass is going to be the worst. It's just the encoder is going to look at that one frame one time and then move on. 2 passes at quarter resolution means it goes over it twice, the first frame at full resolution and the second frame at a quarter resolution. So it looks better than single pass, but not quite as good as 2 passes full resolution, which is 2 passes of the frame at full resolution. I would try setting this to full resolution first. Again, see what the performance impact is looking like. If you're running into issues, lower this. And then profile, just leave at main. Look ahead and psychovisual tuning. Usually look ahead you want to turn off. And then psychovisual tuning can be worth checking, especially if you're streaming FPS games. So it even says, especially in situations with high motion. GPU, this basically just determines if you have multiple graphics cards. So if you have multiple graphics cards, you can pick a graphics card to do the encoding on. I only have one GPU in my system, so I'm just going to leave this at 0. And then max B frames, this can be anywhere from 1 to 4, I believe, or 0 to 4. I don't remember off the top of my head. Yeah, it lets you go to 0. So this just basically is a general recommendation is that 2 is perfectly fine for like basically everything. 3 and 4 and 1 and 0 can look slightly better in very specific scenarios, but usually just leave this at 2 and you're golden. Now, you will have different encoder settings based on what encoder you ultimately select here. So like if I go to X264, you'll see that I have similar rate control and bitrate options, keyframe interval. However, my usage preset here is different. So if you're running X264, once again, bitrate and rate control remain the same. So I stream to Twitch, so I'm going to use 6000 and CBR, keyframe interval of 2. But then right here is basically how demanding the encoder is on the CPU. Usually this, like if I'm running a dedicated streaming PC for X264, I will set this to fast or medium, and that will run perfectly fine. Usually running it any higher than medium overloads the encoder, and then you get frame drops and stuff like that. So you might have to play around with this. Very fast basically works on like every system. There's really no system that can't run the encoder at very fast. But kind of work your way up, do a test stream, and continue to work your way up until it says the encoder is overloaded, and then you'll kind of know where your limit is there. Profile should always be set to high. Profile basically just determines what algorithms and what tricks it can use to do the encoding. High just allows the full encoder options to be used. Tune, leave at none, and then leave this X264 options blank. And then again, like AV1 looks like they have a similar kind of set of options, but I'm not as well versed in AV1 because I, again, stream to Twitch. But if you want to try this out and see how it goes, you're more than welcome to. It actually will probably look better than any H.264 based encoder. Moving on to audio, you have a sample rate right here. Basically, the biggest thing with sample rate is you need to make sure it actually matches your sound device. A quick way to check this is if I open up the settings and if I go over to system and then sound, and then I can go right here and I can see that for my sound device, I have mine set to 48,000 hertz. Basically, this needs to match what you have inside OBS. So again, if you're running 44.1 on your sound device, set this to 44.1. If you're running 48,000, set this to 48. Channel, leave that at stereo. For your global audio devices, this is where you're going to put your microphone and speakers and stuff like that, your headset or whatever. Most of the time, if you leave both of these at default, it works okay, but if you're running into issues, sometimes it's better to specify it. I only have this remote audio option here. That is just because I am remoted into a sandbox machine, but you'll have your microphone and stuff listed here. For peak meter type, usually it's worth setting this to true peak because this will give you a more accurate picture of what your audio is looking like. So if I set that here, it makes this bar here a little bit more accurate. So as long as like I'm talking and this is in the yellow, it's usually a good enough sound level. If it's a little under the yellow, that's most of the time perfectly fine too. You just want to kind of avoid it hitting the red, because if it hits the red, that means you're peaking and you're actually losing some level of audio data that way. What's cool here is you can set a monitoring device. This basically lets you listen to what OBS is actually getting audio-wise. I'll explain this more in another video along with the audio track stuff, because that comes in handy for this. And then you have some hotkeys here, which are pretty self-explanatory. Going over to the recording tab, again, we've already talked about recording path. Recording format. So this basically lets you choose what file type you record in. This actually just changed as of OBS 29.1, so if you're running an older version of OBS, this is going to look a little different, and my recommendation is you update your OBS version to match this. But what's really cool about this is now we can export to Flash video if we really wanted to. There's really not a reason to, but hey, it's there. We can export to traditional MP4, we can export to traditional MKV, but then we also have these options like fragmented MP4 and fragmented MOV. And I'm going to kind of explain what the differences are. So, before this version of OBS, my recommendation would have been to record an MKV, use your GPU, whatever, to do the recording. But then, since MKV doesn't get supported in most video editors, go over to advanced and have OBS automatically remux the MKV to an MP4. Now, the reason you would record an MKV and then have OBS do this conversion is because MKV is a container format for video that is protected against OBS crashing or your computer crashing or you lose power or whatever. It won't corrupt the video file. It'll just abruptly end wherever at the time of your crash or whatever happened. The same could not be said for traditional MP4, and it even gives you a warning here that MP4 will be unrecoverable if the file cannot be finalized. It even says the same about MOV. So basically, it's even telling you right here, consider recording to MKV and then remux to MP4 after the file is finished. Now, the downside to remuxing is that it saves both versions. So every time you record a video, you'll have a 20 gigabyte video that's in the MKV format, and then you'll also have a 20 gigabyte file with the same name that is in the MP4 format. So effectively, you cut the amount of time you can record in half, which sucks. So that wasn't like the best solution either. But now we kind of can get the best of both worlds. If we record in fragmented MP4, we now don't have to remux anymore. That saves us a little bit of time and storage. But now we also get that file loss protection if something happens. Same with fragmented MOV. It also applies there. But usually most editors, MP4 is kind of the universal format, so I recommend just doing MP4. So that's great. That's amazing, actually, that we can do this now. Now, the only thing that you lose out using fragmented MP4 and why fragmented MOV can be better is because you get options of more audio encoders. So you can do PCM audio. For the vast majority of you guys, this is not going to matter. Basically, if I wanted to record FFmpeg PCM 32-bit float here, that gives me the most lossless audio. And if I wanted to go back and edit my video, I could get rid of some of my peaks in my audio and stuff like that. Like, basically for big editing nerds and stuff like that and big audio people, this is going to be amazing. But for the vast majority of you, it really won't matter too much. You can leave this as AAC and, you know, be perfectly content with it. But you'll even see that you lose out on AV1 encoding if you try to do MOV, so you have to use MP4. So that's kind of a personal preference thing. But either way, these new fragmented options are a great addition to OBS. Then we have the same options such as rescale output. You're not going to want to rescale your output if you're recording. You want to record at your native resolution. And then encoder settings. So what's nice about this is that since we are not trying to transmit this data over the internet, we can crank this bit rate. So for recording, if you want to use CBR, you can. I recommend at least a bit rate of 25,000 for CBR recordings, but I've done as high as 40 and 50,000 to get the absolute most. Keyframe interval you can leave alone. Once again, your presets and stuff work exactly the same. You'll have basically the same encoder options as whatever you used for streaming, you know. So if I wanted to, in theory, I could stream on the processor and record on the GPU if I have the resources for it, or I could do both on the GPU or both on the CPU if I really wanted to. The other option that I recommend for recording is CQP if you're using NVENC. And then I usually set this to like a level of 16 or 18. That seems to be good balance between quality and file size. Once again, CQP is great for recordings. And then once again, all of these other settings kind of apply in the exact same way. If you have any questions, feel free to leave a YouTube comment, or if you have my Discord tag, feel free to shoot me a message on Discord. I will catch you later.